Welcome back to the deep dive. So today we have a really interesting engineering problem to unpack. The core question is this: how on earth do you push a perfect professional high-definition video signal for nearly, 12 and a half miles? We're going to get into the specs of the NTI 3GSDI extender to see how they pull it off. Because right away, when you look at the specs, the secret is, well, it's pretty clear. It's all about fiber optics.
It is. The whole system is built around using a single LC fiber optic cable.
Just one cable.
One single cable to handle broadcast-grade SD, HD, and even 3G SDI video. That's really the engine behind that incredible distance.
And this is where it gets fascinating, right? Because the type of fiber you use just completely changes the game.
Oh, absolutely. It's a massive difference. If you're using, say, a standard multimode fiber,
The 50-micron cable.
like exactly, the thicker 50 micron, you get a really robust link, but you're capped at 640 feet.
Which is fine, for an office building or a camp.
For a campus, yeah. But to get that headline number, that 12.4 miles or
Mhm.
20 kilometers, you absolutely have to switch to single mode fiber. That's the super narrow 9-micron cable. The signal loss is just so low over that massive distance.
That jump is just staggering, from 500 meters to 20 kilometers. But that usually means a big jump in cost, too. So what are we getting for that? Is the quality holding up?
It is. 100%. We are talking full HDTV resolutions all the way up to 1080p at 60 hertz. And it supports the key protocols.
Yeah.
SMPTE, 290M, 424M. These are the industry standards you need for professional production.
So no compromises on quality.
None. This is for moving high-end video, period.
Okay, let's talk about the hardware itself. It's a two-box setup, right? A transmitter and a receiver.
That's right. A local unit and a remote unit. Very straightforward.
But what makes them practical for an install? I mean, beyond just being plug and play.
For me, it's the monitoring and the redundancy. The local unit has an SDI loop out.
Oh, that's a huge deal. So you can plug in a local monitor right at the source to see what you're sending.
Exactly. You don't have to wait for a call from 20 kilometers away to know if your signal is good.
And the remote end.
The remote end can drive two separate displays at the same time. Plus, you get integrated mounting brackets, low EMI. It's all designed for real production environments.
And it's tiny. Small footprint, runs on 12-volt DC power, very low draw. That's perfect for remote setups.
And here's where it gets even more specialized. It's not just video.
There's a data component.
Yeah, it supports unidirectional RS-485. So the receiver, the remote unit, can send control data back to the transmitter.
So, like for a remote PTZ camera or something?
Precisely. You could send status updates or pan tilt commands back down that same line without needing another cable run. That's pretty smart.
And how tough are these things? Do they need to live in a nice climate-controlled room?
Not at all. The specs on this are fantastic. The operating temperature goes from -4 degrees all the way up to 131 Fahrenheit.
Wow, so minus 20 Celsius.
That -20 seafloor is the key. That means it can live in unheated roadside boxes, temporary outdoor broadcast setups in the cold.
Yeah.
It's built to be deployed out in the real world.
Okay, but there's always one catch, isn't there? One little detail to remember.
Well, it's less a catch and more a fundamental of system design. The fiber handles the long haul. But you still need your standard RG6 copper cables to get from the video source to the extender and from the extender to the display.
And copper has its own, much shorter distance limits.
That's right. For 3GSDI, you're looking at maybe 100 meters or about 328 feet on that local copper run. You just have to account for it.
So let's pull this all together. This device is a very specific solution to a very high-stakes problem. It's about getting pristine 1080p video over insane distances with a single fiber, and it has the control and monitoring features to make it reliable.
And that really leaves you, the listener, with an interesting thought. What kind of project becomes possible with this? Think about a massive live event like a marathon where you have cameras spread across a 12-mile course. When you can connect all those remote setups in potentially harsh weather back to a single control room with broadcast quality and data control. What kind of workflow does that unlock that was simply impossible before?